In this section, we are going to connect what we've been learning about deductive reasoning to algebra and geometry, and ultimately we'll be heading toward learning how to do geometric proofs, and so we'll look at that a little bit later in this lesson. Some of the things that we use all the time and we don't really always necessarily call them out or label them when we're doing algebra are these properties of equality. So if we have any real numbers a, b, and c, we have all of these 8 different properties that we often use. The addition property just says you can add any number, the same number, to both sides of an equation and it will still be equal. Likewise, you can subtract, multiply, or divide by any number. The exception for division is obviously we can't divide by 0. The reflexive property says a number is equal to itself. Symmetry says if A is equal to B, then B must equal A, where the order doesn't matter. Transitive property says if you have 2 things equal to the same thing, they're equal to each other. And the substitution property says if A is equal to B, then you can replace B or A in any expression. The distributive property also allows us to represent things in different ways. And we're going to go ahead and look at some examples where we use deductive reasoning to solve equations, and we will be justifying each of our steps as we go through and solve these equations. So let's take a look at this one. It says, what is the value of x? Justify each step. We are given that angle AOM and MOC are supplementary. So AOM and MOC are supplementary. Well, what does the word supplementary mean? The word supplementary means that they add to 180 degrees. And we also can tell from the diagram that AOM and MOC are a linear pair. They share that same vertex. And so we'll start off saying that the measures of the angles add to 180, and that's the definition of being a supplementary angle. That was a given. So from here now we can say 2x plus 30 plus x must equal 180. We can come up with this equation where we remove all of the labels for the angles and strictly use algebra, and that's our substitution property. Now we can add these 2 things together, the 2x and the x, to get 3x. The book calls this the distributive property. I would argue that that's really the commutative property, that we are adding the like terms together. The next step then, we are going to subtract 30 from both sides to get to the next step. You can see that we've subtracted 30, so that must be the subtraction property. And lastly, we need to divide by 3 on both sides, so that would be the division property. So you're going to go through and you're going to write out each of these steps. They follow logically one from another. You know, it's just simply showing your work in algebra, but this time you have to justify each step using one of those properties. So here's an example for you. Go ahead and pause the video and see if you can come up with the steps and the answers on your own, and I will give you the answers when you come back. Alright, I hope you took some time to try this on your own. We are given that ray AB bisects angle RAN. So they're telling us that this ray is an angle bisector of angle RAN. Well, what does that mean? That means that angle RAB and angle BAN are congruent, and that's the definition of a bisector. Well, where can we go from here? Well, it looks like angle RAB is given this letter x, so let's go ahead and substitute the values in. So we can say x is equal to 2x minus 75, and now we need to combine our like terms. If we subtract 2x from both sides, that's our subtraction property. And then combining those like terms, we end up using our substitution property. X minus 2x is negative x. And lastly, if we multiply both sides by negative 1, we get x equals 75. The following properties are very, very similar, almost exactly the same as our properties of equality, but in these examples we use our congruence symbols. They're really no different other than we have congruence instead of equality. So they're pretty much interchangeable. So let's go ahead and use some of these properties to solve some problems. Our directions say, what's the name of the property of equality or congruence that justifies going from the first statement to the second? Our first statement is 2x plus 9 equals 19. How did we get to the second statement? Well, it looks like we subtracted 9 from both sides, so logically that would be the subtraction property of equality. In example B, we have the congruence statement here. You can see we have congruences, so it's going to be a property of congruence. If angle O is congruent to angle W, and angle W is congruent to angle L, how do we get from angle O congruent to angle L? Well, that looks like our transitive property of congruence. And then letter C, if angle E is congruent to the measure of angle T, and the measure of angle T is congruent to the measure of angle E, well, those are just the same statement in a different order. So that is our symmetric property of equality. Okay, and just notice if it has an equal sign, it's equality. If it has a congruent sign, it's a property of congruence. All right, so here's a couple more. Go ahead and try these. Pause the video, and I'll give you the answers in a minute. All right, so letter A. If segment AR is congruent to TY, TY is congruent to AR. Well, that's very similar to the example C up here. That's our symmetric property of, and I didn't put this in here. You can just put the symmetric property. It would be the symmetric property of congruence. Letter B, what's happening between the first step and the second step? We got rid of the parentheses by using our distributive property, and that would be of equality. Letter C, how did we get from step 1 to step 2? Well, we multiplied by 4 on both sides, so that's our multiplication property. And letter D, what property justifies the statement the measure of angle R is equal to the measure of angle R? Well, that would be considered the reflexive property. Sometimes that's also called the identity property. So here we go with our proof. So proof is a convincing argument that uses deductive reasoning, and it logically shows why a conjecture is true. We are going to be using two-column proofs where we have statements on the left side and the reasons for those statements or the justifications on the right-hand side. So this is just a general example of what a two-column proof would look like, and we're going to go ahead and actually follow through with this exact example on the next slide. So we want to write a two-column proof. We're given that the measure of angle 1 is congruent to angle 3. It's equal to angle 3. We want to prove angle AEC is congruent to the measure of angle DEB. Okay? So we start with the measure of angle 1 being equal to the measure of angle 3, and that is just a given statement. That was given to us. From there, we can go ahead and say the measure of angle 2 is congruent to itself by the reflexive property. So now what happens if we add these two, the measure of angle 1 plus the measure of angle 2, that has to be equal to the measure of angle 3 plus the measure of angle 2, and that's our addition property if we just add angle 2 to both sides. So now measure of angle 1 plus angle 2, that's the angle we want. That's the measure of angle AEC, and 3 and 2 gives us angle DEB. So now we can say that was our angle addition postulate. Okay, you could also say substitution there, I think would be appropriate. So our last step is the two angles are congruent by substitution. Here's an opportunity for you to go ahead and try to prove this on your own. You are given that segment AB is congruent to segment CD. You want to prove that segment AC from A to C would also be congruent to segment BD. So remember your first statement that you're going to write, you're going to go ahead and write that you have, I'll just get you started on this one, AB, and use your notation, segment AB is congruent to segment CD, and your reason for that is given. And it's probably not a bad idea for you to go ahead and label by number each of your steps and give your justification for each of those. So I'm going to stop there, and I'm going to let you work on that on your own and bring your answer to class, and we can talk about that. See you next time.